Assalamualaikum warahmatullahi wabarakatuh. Let me introduce ourselves. We are from the Ambatron group, and here we are discussing the case of the sixth case study entitled Comparative Model of Education Support System for Student Laptop Selection. Okay, so here we use two methods, namely SAW and TOPSIS, and the result of our system in laser laptop selection and recommendation. Therefore, we are talking the title of the report here, namely Discussion Support System for Student Laptop Selection using SAO and TOPSIS methods. Okay, next slide. Let me introduce myself. My name is Muhammad Abdul Rafiansyah, the group leader of the Ambatron group, and my two friends who helped in the development of the system are Siti Satyani and Destia Naila Nabil. Okay, next slide. So here we are partnering with a computer shop whose source address in Tanjung Kara, more precisely in Ratulangi. A little information is that we did not conduct direct research on the site, but we have permission to partner directly towards the owner of TV Kiazaya. So here we do not have any video documentation regarding the partner.
On this slide, I will explain the background of the problem. Laptops play an important role in supporting student academic activities. Students use laptops to complete assignments, attend online class, conduct research, and run educational software. However, there are many laptops brand, specification, features, and price ranges available on the market. Because of this, students often find it difficult to choose the most suitable laptop based on their needs and budget. Several problems were identified. First, there are many laptop alternatives available. Second, laptop selection is often based on subjective judgment. Third, students need to consider multiple criteria at the same time. Finally, there is a lack of objective decision-making tools for laptop selection. Therefore, a more systematic and objective approach is needed to help students make better decisions. To solve this problem, we propose a decision support system or DSS to help students choose the most suitable laptop based on multiple evaluation criteria. This system uses two decision-making methods, SAW and TOPSIS. The SAW method includes four main steps: data normalization, weight assignment, preference calculation, and alternative ranking. The TOPSIS method includes determining the positive ideal solution, determining the negative ideal solution, calculating the distance of each alternative, and producing the final ranking. By applying these two methods, the system can provide objective laptop recommendation and compare the results generated by SAW and TOPSIS. The expected outcome is a more accurate and reliable laptop selection process for students. On this slide, I will explain the laptop evaluation criteria used in the study. The laptop selection process uses 7 evaluation criteria. Each criterion is classified as either a benefit attribute or a cost attribute. The first criterion is price, which is a cost attribute because a lower price is preferred. The second criterion is RAM, classified as a benefit attribute because high RAM capacity provides better performance. The third criterion is CPU score, which is also a benefit attribute because a high score indicates better processing performance. The fourth criterion is SID capacity, classified as a benefit attribute because large storage is preferred. The fifth criterion is battery, which is a benefit attribute because longer battery life is more desirable. The sixth criterion is laptop weight, which is a cost attribute because a lighter laptop is preferred. The seventh criterion is warranty, classified as a benefit attribute because a longer warranty period provides more value and security. The classification is important because it is used in both the SAW and TOPSIS methods for normalization and ranking of laptop alternative.
On this slide, I present several previous studies that serve as a reference and foundations for the development of this decision support system for laptop selection using the SAW and TOPSIS methods. The first study was conducted by Katulistiwa et al. 2023. This research applied the SAW method to laptop selection and successfully generated recommendations based on multiple evaluation criteria. The second study was conducted by Firmansyah et al. 2023. This research compared the SAW weighted product and TOPSIS methods and found difference in the ranking results produced by each method for laptop alternatives. The third study was conducted by Rizaldi, 2024. This research performed a comparative analysis of the SAW and TOPSIS methods and concluded that both methods are effective in supporting decision-making process. Based on these previous studies, it can be seen that the SAW and TOPSIS methods have been widely used and proven effective in assisting laptop selection based on multiple evaluation criteria. Therefore, this study adopts both methods to generate laptop recommendations and compare their ranking results in order to support more objective decision-making. On this slide, I present the application and technologies used in the development of the decision support system for laptop selection. First, Visual Studio Code or VS Code was used as the primary source code editor for developing the application. Second, HTML was used to create the structure and content of the web page, ensuring that information can be displayed properly to users. Third, CSS was used to design and style the user interface, making the system more attractive and user-friendly. Fourth, JavaScript was used to implement the systems functionally and provide interactivity within the application. Fifth, JSON was used for data storage and data exchange throughout the system. Finally, Google Chrome was used for testing and running the web application during the development process. By combining these technologies, the system was successfully developed as a web-based decision support system that assists students in selecting the most suitable laptop according to their needs. After discussing the technologies used in the development process, I will now explain the workflow of the decision support system. On this slide, I explain the workflow of the decision support system that utilizes the SAW and TOPSIS methods to generate laptop recommendations. The process begins with the user input stage, where users enter laptop alternatives, evaluation criteria, and the corresponding weight for each criterion. Next, the data process to the data processing stage. In this stage, data validation, normalization, and weight matrix preparation are performed to ensure that the data is ready for analysis. After the data has been processed, the system performs calculation using two different methods. The first method is simple additive weighting or SAW. In this method, preference values are calculated based on the criteria weights and alternative scores, resulting in a ranking of laptop alternatives. The second method is technique for order preference by similarity to ideal solution or TOPSIS. This method determines the ideal solution, calculates the distance of each alternative from the ideal solution, and generates an alternative ranking. The results produced by both methods are then evaluated in the comparative analysis stage, where the ranking outcomes for SAW and TOPSIS are compared. Finally, the process reached the recommendation result stage, which provides the best laptop recommendation along with the final ranking output. Through this workflow, the system is able to analyze laptop alternative based on predefined criteria and weights, compare the result of the SAW and TOPSIS methods, and generate the most suitable laptop recommendation for students.
Okay, so here I will discuss the appearance and feature of the website. So, in slide 10 to 15, we have include a brief overview of our website, but to make it clearly, I will show the website differently. Okay, first, this is a dashboard or homepage. This page only displays the system main information and a few gimmick widgets. Next, this display from the 7 criteria used: price, CPU score, RAMs, storage, battery life, weight, and warranty. Below that is a budget finder. This is actually just a gimmick feature displaying the best laptop based on general categories and their price. Next, because it aligns with my case study, I use 3 faculty at Teknokrat Indonesian University as the benchmark for recommendation, and 1 general category. Here there are options range from budget, brand, RAM, and storage. You can customize them. Then here is a display of all the laptops. There are a total of 500 laptops for variable brands. You can simply search for the desired brand on the search bar. Next, there are the criteria weight setting. The presentation for each faculty are already adjusted. But if you want to change them, you can simply adjust when them 100%. And this is ready to run. The result of the SAW and TOPSIS calculation are here, and the result of the SAW and TOPSIS calculation and here. And can also be found here. These are the rankings and analysis results for the laptops we selection early. There's also a visual scan and a comparison table for the 2 methods. There are the results for the best laptops based on the calculation for both methods. You can also print the result here. And there are also a recomparison buttons reset. And there are also calculation methods, see here. To delete, just use this button. Finally, here's an explanation and guide for the 2 methods used, SAW and TOPSIS. And that concludes the web session. For the calculation, the system successfully developed a web-based DSS for laptop selection using the SAW and TOPSIS methods, providing consistent, objective, and effective recommendation based on multiple criteria.
Well, maybe that's all for our group. We end with wassalamualaikum warahmatullahi wabarakatuh.